All right. Hey, everyone. Hi. I have to admit, I'm a little surprised to see so many of you here. So my name is Kenneth, which you know when you decided to come here. And I work for Treehouse, which is an online education thing. We teach people to program. We've got courses on pretty much anything you want to learn. And we keep adding new stuff. I'm the Python teacher there, so I just teach Python and Django and Flask and all that stuff. So here's the way this is going to go. We're going to talk about a bunch of stuff. I'm going to write some code. I'd like you to write code along with me. If and or when you get confused, interrupt me. If I make a mistake, jeer me. It's fine. Yeah. So just basically relax. I've got a bunch of stuff I want to go through, but if we don't go through it all, it's cool. I gave it all to you on the internet, so you can go through it later at home. I'm going to be using Python 3 for all of this. You don't have to use Python 3 if you don't want to. You can use Python 2. A couple of things are going to be different. I'll do my best to point those out where and when they're different. If you're writing something and it doesn't work, let me know. Chances are good it's Python 2, Python 3 stuff. All right. So let's talk about OO, object-oriented programming. Anybody completely brand new to that concept doesn't know what OO is at all? Yeah? All right, cool. So in programming, we have a lot of different ways of approaching solving a problem. We might write procedural code that just goes top to bottom. Maybe there's a loop or two in it. Maybe there's a function, but we're not really too concerned about dividing things up. This is the way, if you wrote code in BASIC back in the day. That's kind of the way you had to write code in BASIC. You get to use gotos, though, which is fun. And then we have functional programming, where people purposefully break things up into really tiny little functions, and those functions all basically chain together, and you get to manipulate your data that way, which is awesome and really fun and good, but doesn't always solve a lot of problems. And then we have object-oriented programming. And in object-oriented programming, you make objects in your code that represent real-world things. Typically, I think about objects as being nouns. They're things that exist and that you can do something to. They're not actions that you take, although they can be. They're not adjectives that describe something, although, again, they can be. Usually, they're objects. It's really handy for real-world stuff because usually you're thinking about a real-world thing, right? If you're making software for a bank is a real-world thing, so you can make an object for a bank, and then you can start giving that bank stuff. We have names for that stuff, which we'll get to in a minute. Another great thing, though, about OO is that everything in Python is already an object. Every single variable you make, every type of data that you use, every function that you write, every class that you write, every module that you create is an object already. So getting more comfortable with objects makes you more comfortable with Python in general. Okay. That's my page of talking. Okay, objects are usually nouns. Like I said, they're a thing, and things have attributes, right? If we're talking about, a shoe. A shoe has a size, and it has a color, and it has how long the laces are, and it has whether or not it has laces, or if it has Velcro, and it has the type of tread that it has, and all this stuff, right? These are all attributes of a shoe. So if I'm making a shoe class, I can give my shoe all these attributes. Attributes are adjectives, more or less. Objects also have methods, which are like actions that object can take. A method is just a function, but since it belongs to an object, we call it a method so that you know what I'm talking about when I say method versus function. We like names in Python. Okay, so objects exist. They're real-world things turned into code, or concept-y things turned into code. They have attributes. They have methods. So let's make a couple. Actually, let's just make one. Get rid of this. All right. So in Python, all of our objects start with the word class. And we're going to make a shoe. I kind of sold myself short on this one a while ago, but there we go. So if you're doing Python 2, you're going to want to do this instead, because otherwise you get an old-style class and they act weird. So don't do that. Python 3, you get to type less. Woohoo!
Are both accepted in Python?
They are. Yeah, Python 3 is fine. What happened, so we had old style classes in Python 1, which were weird. And then to fix that, they gave us new style classes in Python 2.4 or something like that. And you had to extend your classes from objects so that they got all the behaviors of objects, so they acted like how people think of classes as acting. And in Python 3, they went, well, if you always have to extend object, why are you still doing it? Why not just make them automatically extend object? So that's what they do in Python 3. So those two lines, exactly the same in Python 3. All right. And then, like I said, we'll give our shoe a size. And we'll give it a color. I think I'm all right. Okay, cool. Thank you. So, our very first object, it's a shoe, and according to its attributes, it has two of them, one of which is the size, which is 9.5, and a color, which is the string red. So, anybody here unfamiliar or uncomfortable with the idea of namespaces? Get the idea of a namespace? Namespace is just an area in which a particular name has meaning. So, size has no meaning anywhere except inside of shoe, right? But if we were doing another, you don't have to do this part, drink. So those two sizes have nothing to do with each other, right? We know that because of their namespace. The size of a shoe and the size of a drink are not at all related. So because of namespacing, we know that, or Python knows how to find which thing we meant. All right. Wow. Some days I cannot use my code editor. It's awesome. Okay, so we have a shoe and it has an attribute. Let's give our shoe a method. Methods are functions. Functions begin with def, right? And what do you do with a shoe? You put it on. And the one thing that's weird about object methods versus functions is that object methods always take the same first keyword. It doesn't have to be self, that's by convention. And self there refers to the instance that you create of a shoe. So you make a particular shoe, your pair of shoes that you're going to wear. Self there always means my shoes. It'll be more solid in a minute. We'll make this function do something. You put on your shoes. Oh, that O is going to bug me. All right. And I'll actually make that color if that makes more sense. Yeah, it makes more sense to have colors than it does sizes of shoes. Because you don't generally put on multiple sizes of shoes, do you? All right, so the self here refers to whatever instance I'm currently working on. Now, I can have multiple instances, and I will have, and each one of those gets to talk about their own color of shoe. All right. And now we've made an instance of our shoe. And so if I was to, at this point, shoes.color. That's not what I wanted you to do. Oh yeah, it is. It did the right thing. So when I run this script, I get that my shoe color is red and my shoe size is 9.5. Okay, so my shoes, the self points to the my shoes variable. It always knows how to get back to itself. And we've got that thing. All right, everybody comfortable with the idea of creating an object, giving it an attribute, and giving it a method that refers back to the instance itself? That instance part's going to become important in a minute. All right, cool. let's talk about a gotcha, because gotchas are fun and what most of programming is about. All right, so I have my shoes, which is a my shoes. It's a shoes instance, right? I want to go change the color of my shoes. So my shoes.color is equal to black, even though that's a lie today. And then I'm going to make your shoes. And something I've discovered as I was creating this talk and now giving it, shoes is really hard to type. Repeatedly typing shoes is the most horrible word. See, I'm gonna type shores, I'm gonna type she's, I'm gonna type all sorts of things. Okay. So if we run this again, we get a pretty expected output, right? I changed my shoe color to black, so it prints out black instead of red. It still prints out 9.5 because that's the size, and then it prints red for your shoes because that's the default color, right? Okay. Here's the fun thing. Any guesses on what let's take out these first two lines. They don't even matter anymore. Any guesses on what color is going to be printed out for your shoes? Yeah. Can you tell me why? Right, but I made an instance already. Shouldn't it be red now? Right. If your instance doesn't have it set explicitly, Python doesn't store things that it doesn't need to store, so it goes, oh, well, this instance doesn't have it. Let's go see what the class has. And the class now has blue, so Python goes, oh, you must want blue, so here's your blue. So, not that you're going to likely do it, but don't change your classes during runtime. Generally a bad idea. All right, so we can make a class. We can make attributes. We can make methods. We can screw with people's expectations of what the class value is going to be, or the class attribute is going to be, and we can set it for an instance, because here, this is setting it on that instance. Wow, that's not what I wanted to do. So if I print my shoes.color, it's going to be black. It's always going to be black because that's what I set on the instance. All right. That little scoping thing occasionally does bite people. Thankfully, not too often. Now let me look at my plans. I think I had a challenge in here. I did. So take a quick minute, everybody, and see if you can add a new method to your shoe class. I don't care really what it does. How about make a take off method for taking off your shoes, and you can mention the size in this one. I like to make people code. And if you've been cheating and looking at my file bar, you know we're talking about more than just shoes today. All right, anybody having issues setting the new method? Oh, and if you don't want to raise your hand and ask a question, but you have one, there are note cards up here if anybody wants to write down questions. I should have remembered to bring Post-its. teacher friend of mine has a thing. You put a Post-it on your computer if you have a question. You don't have to raise your hand. It's awesome. All right, everybody good on their method? Feel like you're making good progress or you're done? All right, so let's talk about, if you've heard me using the word instance over and over again, that's on purpose. Our attributes, not really the attributes, our methods, that's where it makes the most sense, belong to an instance. So every time you make an instance of the shoe class, you do my shoes equals capital S shoe parentheses, you're making an instance. That my shoes instance, the method belongs to that instance. It always comes back to that instance when it looks for self. You don't have to deal with instances in Python because sometimes it doesn't make sense to have an instance. Sometimes you need other stuff. So, if I say decorator, anybody know what I mean? Or not know what I mean? Anybody really lost on decorators? All right, so decorators, if we jump, I mentioned functional programming. They're a big thing in functional programming. A decorator is a function that takes, usually it's a function, that takes some other thing, usually a function, and wraps its own little bit of behavior around it. So maybe you want to log every single time a particular function is called. So you can make a decorator that all it does is log, hey, somebody called my function, and you put the decorator onto the function. We're going to do that in a second. And then anytime that function gets called, that decorator gets run. So it's really handy. If you've built views in Flask or you've done login required in Django, you've used decorators. They have a little @ symbol. So let's talk about a decorator. So class method is a decorator. Starts with a little @ sign, which looks like something wrapped around an A. That's how I remember it. And so a class method is a method that doesn't need an instance, it needs a class. Which sounds weird until you start trying to create one. All right, so normally methods on classes, not methods on functions, methods on classes, start with self. With a class method, your first argument isn't the instance, it's the class that the method belongs to. You can't use the word class because that's protected in Python, so CLS, class with a K, class with like 3 S's, whatever you want to use for that first one. I kind of like the class with a K. I think that one looks kind of cool. It's like all hackery, but that also gets into like metaprogramming stuff, is where you'll see that all the time, so it's best to avoid it unless you really know what you're doing. So normally class methods are used when you want to be able to call a method on a class. It makes sense for that method to belong to the class, but you know you won't have an instance yet. Where does that usually occur? When you're trying to create an instance of the class, right? Or again, you get into metaprogramming stuff and you're like, I need to go up the class chain, but promise you I'm not going into that today. So let's make a shoe. And we're just going to instantiate whatever the class is. I don't even care what the class is, just so long as there's a class. So shoe is this class. And then I'm going to do size and color is description.split. Oh, not shoes. So we're making a constructor for ourselves, basically. If you've played around with JavaScript a lot, you've gotten used to the idea of creating constructors because their class stuff is weird. And so what we do is we're like, okay, we've got this class method. It belongs to this class. Whatever this class happens to be called, make me a shoe. Take the description, split it on white space. I'm assuming there's only 2 bits. I should probably make that safer, but whatever. We're going to do a float on the size. Again, should be safer. And then we're going to assign the color, and then finally we return this new class instance that we created, right? Because we created an instance here, and then we're going to return it here. The cool thing is that I don't have to have a class now. So I don't have to do my shoes, see? Equals shoe. I don't have to do that. I can do shoe.create, and then I give it my description, and we'll say 10 blue. So the benefit, let's run this to make sure I did it right. I did, woo! The benefit is that you can now control the constructing of the instance. Like, we're going to get to the init method in a little while, which is what runs when an instance is initialized. That already has an instance by the time init happens. So if you're like, I can't have an instance by this point, I just need to be able to create one through my own code. If you played with Django models and you do like, model.create, where it runs through the entire construction process of creating this instance in memory, setting all the attributes, validating whatever validators you've set up, and then saving things to the database, that's using a class method. Because the instance doesn't exist until somewhere in that creation process. So if I know that my class is really complicated to make, or I know I have to do some processing to be able to make my class, then that's where class methods come in handy. Yeah?
Do class methods need to be defined within classes or outside?
As far as I know, they have to be inside the class. I'm sure there's a way, if you use class method as a non-decorator, I mean, decorators are ultimately functions, right? So you'd be able to call it, I don't even know what the signature would be, but you'd be able to call it like on its own and probably pass in a class. So you could probably define those outside of the class. That seems really unintuitive and hard to me, and not a process you would normally take unless you are overriding a class you don't have control of. But in that case, extend the class and then write your class method inside your extended class. That would be way more likely, I would think. Yes? Yeah, I'm able to control it outside of the normal object creation process. Right. Yeah, and if for instance we're dealing with a shoe here, so this is like super simple, right? But maybe we're dealing with we'll go back to bank, like a banking transaction. You might have to create multiple objects as part of creating that single transaction, or you may need to go fetch data from somewhere else, or use other bits and pieces that you don't have or don't want to have to require when you create an object. So doing it inside of a method like this makes it to where, okay, I can put all that concern into one area instead of having to hoist it onto the user or, do some other sort of magic. Because the less magic you do, the better. The downside of the class method decorator? Lots of times people don't notice them. I mean, they don't look like any sort of special method if you just inspect the object. Like if you do a dir on the object, it doesn't look special or unique as far as that method goes. So they're easy to overlook. As far as performance or whatever goes, there's not really a downside. I mean, a method's a method. I suppose it could also be a place where people start to get a little bit too clever and write themselves into holes. Yeah.
What happens if you run the class method off, try to run the class method off you do my shoes.create?
It should fail. Let's give that a try. I got orange shoes on now, apparently. Yeah, like nothing happened at all, I don't think. Oh no, I got one. Okay. So it'll work either way. Which makes sense. It's able to go back to the class. Yeah. Yeah. Yeah, it's able to get back to the class by being passed an instance of it. The next thing we're going to talk about, I don't believe has that ability. Python's pretty good at, on a lot of this stuff, figuring out what you meant to do, even if it's not what you actually did. Most of the time, stuff will work even if you provide an instance of a type instead of an actual type or an object. Okay, any other questions about class method? I promise you won't write a whole lot of these throughout your career, or the next one, but they're both good to know about. Okay, cool.
But in terms of questions from the room, they need to be repeated. Yeah, so I had to turn down the level a little bit for the room because it was getting some, it's going into the red feedback wise. If you'd like me to turn it back up a little bit, I can. Did it go off again in the room? Maybe kind of could repeat the question.
Yeah, with all the talks I give, you think I'd be better at that, but I keep forgetting to do that occasionally. I will do my best, though. If I forget, Chris, just yell at me, and I will repeat it, and then go back and answer again. Okay, so class method, we're okay? All right. So now let's think about static method. Another decorator, but a static method, unlike an instance method or a class method, does not require an instance or a class. This is really just where design comes in, and you're like, oh, it makes a lot of sense for this method to belong to this class. Even though it could just like go live on its own somewhere, it makes sense to keep these things grouped together. So, some of these also are very hard to come up with examples in. For shoe and shoes, yield shoe dot create shoe. Ha. Sorry, I gotta look at my notes real quick. It's not stealing if you wrote the code yourself earlier, right? Okay, so we have the static method called shoe rack, and it just takes a thing called shoes. And then I'm assuming it's an iterable. So for shoe that's in shoes, I'm going to create a new shoe and give that shoe back through using yield. I could use no, I could not use return here. Return would fail because we're inside of a for loop. So what this means is I can do a thing like shoe.shoerack, give it a list of shoes I want to be in that shoe rack, and then they all exist in my shoe rack closet thing now. So shoe rack could live wherever you want it, right? It does nothing special as far as the class is concerned. But design-wise, it makes sense to keep it with the class. Because, you know, shoe racks and shoes go together. I'd probably make shoe rack a class on its own, actually, but contrived examples occasionally have to exist. Okay, so the difference between class method and static method. So a class method operates on the class itself instead of on an instance of the class. Or that's the plan. As we showed, you can use it on an instance, but ideally it works on the class and not an instance. It doesn't care about having an instance in other. And so static method doesn't care about the class or the instance at all. It doesn't need either one of them. It doesn't expect either one of them. It has nothing to do with the class. It's there because logically it belongs to the class, not because it actually works with the class. Right. It's a function that's attached to the class. It just happens. Yes, I still have to call it with the shoe in front of it because it belongs to that class. Like it's in that class's namespace. So to get into that namespace, I have to use the shoe class, the capital S, and then I can call that method. But when I call that method, it never gets an instance or the class passed to it. So when Python calls an object or an instance method, it passes the instance to the method as self. When it calls a class method, it passes the class or an instance of the class to the method as, in this case, CLS, right? When it calls a static method, it doesn't give anything to the method except for whatever arguments you gave the method yourself. So, yeah, static method is not super duper common. It's really handy design-wise. Like you find yourself, oh yeah, this makes total sense to have in this class. Static method, stick it in there. But lots of times you'll be like, it makes more sense to have it in like a utilities module or to have it available somewhere else that I don't have to go into the class to get. Okay, any other questions about static method or class method or instance methods? We're going to get away from methods for a little bit. That way I don't have to say the word method over and over again. All right, so object-oriented programming, we're making objects all the time for stuff. You don't always want to make your own methods, though, because like any good programmer, you're lazy. So object-oriented programming gives us this amazing thing known as inheritance. It kind of works like DNA, a little bit, sort of. One or more classes go in, and another class comes out. That's hard to do with genetics with only one class, but let me have the analogy. Lots of times you'll see this done for people who make you'll take the list class and then make something that works like a list, but it's not exactly a list, or the dictionary class, but it's not exactly a dictionary. There's a whole lot of hidden stuff there, so I don't want to jump to that. Let's just make our own classes that do different things. All right, so I'm going to make a monster, and it says rar. And when it attacks, we print monster cries and attacks. And give up, because all good monsters should give up. Monster throws down its weapons, runs away. All right, I'll give you a minute to type that in, because I have to go and give you a bunch of code. All right, so nothing new here, though, right? This is all just like our shoes, only now they bite us instead of cover our feet. Wow. So normally people, when they talk about inheritance, they do like animals, pets, cats and dogs, which I find is like the worst analogy ever because it's been done so many times. So I do monsters. It's fun. And you know, what's not to say that combining a goblin and a dragon creates some new thing? It's your world. And obviously, don't worry about getting like all the print statements and stuff exactly like I do. None of that's super important. It's the concepts that matter. Okay, so we're making a game or the real world or whatever, and we need another kind of monster. And we want it to basically do all the things that monster does. We want it to be able to attack and give up and have a sound. We don't want to copy and paste all this stuff though, right? Because maybe monster gets some new stuff and our new monster should have that stuff as well. So we're going to make a troll. Trolls inherit from monsters because they're a type of monster. Or sorry, they inherit from monster, not monsters. That won't work. I'm going to say that trolls have a bridge, or they can have a bridge. By default, they don't have a bridge. They probably live at home under mom and dad's bridge. And so we're just giving them a new attribute. So now I can demonstrate this in a little bit, but monster doesn't have a bridge attribute. Only troll does, right? Because we gave it to troll, we didn't give it to monster. Inheritance doesn't work up the chain, it works down the chain. And we can override stuff in our new one too. So for instance, a troll wouldn't say rar, a troll would probably say, well, actually. And there we go, we have our troll. God, I was so hoping that joke would work, thank you. I thought of that one at like 7 in the morning yesterday, and I was like, yes! All right, so we have a monster, we have a troll. Troll has all the attributes that monster does. It has all the methods that monster does. It has everything that monster has. But it also has a new thing, which is bridge, which is set by default. And it has a new sound. So we can't go easily from troll up to monster's sound. We can, that's climbing the inheritance chain, but it's not likely to be done. You don't have to worry about doing that. All right. Any questions? Do I need to show like that monster doesn't have bridge or anything like that? You're all willing to accept me blindly on faith with that one? All right, cool. Yeah, question.
So for troll, if we were not defining sound as well actually, all sound for troll would be rar.
So if on troll we had not defined the sound attribute and we called troll.sound, would we get the rar? Yes. So you remember before how we had the shoe and we hadn't defined a color and we went and changed the shoe color on the class, and Python went, oh, okay, and went up to the class, right? So Python will do the same thing here. It goes and looks at troll and says, does this class have a sound attribute defined explicitly? It doesn't? Okay, what does the parent class have? And it goes and looks at the parent class. And if the parent class didn't have sound either, like maybe we did, troll.shoesize, that goes up and looks at monster. Monster doesn't have a shoe size, and so then Python throws an attribute error and says, that attribute doesn't exist on any of these classes. I don't know what you're talking about. You need to fix your buggy code. So yeah, it does its best to find it. Like it will literally just keep climbing up that chain to try and find where that thing is, but if it can't find it, it can't find it. Okay, so we're good on this. Yeah? All right, so let's talk about super. Super is fun. Okay, so in our troll, I want to override attack. And I want to have happen what happens in monster. I want it to print out the monster cries, whatever, and attacks. But I want it to do something else first. So let's add that in. So I'm going to print out the troll says something mean about you. And so at this point, let's just... All right, we're going to have the troll attack. And it says the troll says something mean about you. So what's there in monster never happened, right? I just have the troll says something mean about you. But I want what happened there to happen. So how do I go about doing that? I can copy and paste it. I could do monster.attack, but that's kind of not fun. So I don't want to do either of those. So I'm going to use a method known as super. Again, for you Python 2 folks, this is going to be a little bit different. You're going to do troll and then self. In Python 3, you just type less in Python 3. It's so great. You don't have to remember to divide by floats. It's wonderful. You have to put parentheses around your prints, though. That's the only problem. Okay, so any guesses on what super does? Super goes and looks at the super class, the parent class. I kind of wish they'd called it parent instead of super. It goes and looks at the super class and says, what does the super class do for this method, for this thing that you want me to do? So in this case, we said, print out this message, and then go do whatever the parent class says to do. So we get the troll says something mean about you, the monster cries, well actually, and attacks. Well actually isn't a great battle cry. But whatever. No one accused trolls of being clever. Where super is really handy is where your parent class does something really, really useful, but you need to modify it just slightly. Maybe you have, my most common example is like in Django with class-based views. I write a lot of class-based views in Django. All my views are classes. All my views have parent classes because they're classes. And so, say template rendering, right? There's a method that renders a template. It sends this bunch of data to a template file, creates the HTML, and sends that HTML out to the user's browser. Now, if I want to change anything about that process, I either have to write that entire function all over again, or I change the little bit that I want and then call super, or call super and then change the little bit that I want. And so now I didn't have to do all that work myself. I was able to take advantage of the fact that the class already did it and then just do the thing I needed to do. Super is really handy, and it's also one of those things that becomes really confusing, especially if you don't know how many times super gets called. Ideally, it goes all the way up the chain. Mm-hmm. 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 So the question is, let's say you have a chain of like 5 classes that A to B to C to D to E. That's 5 letters. And E calls super. Where does that go? So it goes to D, and it sees if D has that method. Now you're getting into my memory here, so it may or may not be right. If I remember correctly, if D doesn't have it, it'll go and keep looking up the chain. Ideally, though, you're extending, we'll say it's the same method, right? So E calls the method and has super, and that goes to D, which has the method and calls super, which goes to C, and has the method and calls super, and goes to B, and has the method and calls super, and A, and eventually it resolves the entire chain bottom up, and you get, or whichever order it was called in, and you get the benefit of that entire inheritance chain. That's not always the case. That comes down to design decisions, right? At some point, you might cut it off and be like, nope, this is where it ends. This is the thing that has to happen every single time. I don't care what came before or what comes after. And that's where documentation comes in. All right. Any questions about super? Anybody super lost? Yeah. So what about multiple inheritance? Most of the time, that's not a problem. Some of the times, though, you encounter a wonderful thing called the MRO, or Method Resolution Order. Where this really comes in is I extend from multiple classes. So just, I know this doesn't exist, but we'll say there was another class called Internet. I can extend troll from both of those, and troll gets the attributes of both of them. We get a union effect. Internet doesn't exist, so don't try and run that. But if I call super and both internet and monster define attack, sometimes you'll get the MRO, which is where Python goes, I don't know which class to go to first. Most of the time it's cool because you'll have an order and both of them call super, and Python works its way, I think it goes to internet first and then monster, and then it would go to object ultimately. But if that's not the correct setup or it's a little weird, that's where you get this method resolution order problem, and it doesn't know which one to go to. And you remember how I said you could do like monster.attack? That's what you do to fix the MRO. You tell it explicitly which one to go to, and it figures it out. Yeah.
So if you had a monster and it had shoes also have a sound. Squeak.
Okay.
How does it know which sound to do?
So we have a monster, or we have a troll, which inherits from monster and inherits from shoes. Both of them have sounds because monsters make noise and shoes squeak. Which one does it go to for sound? Again, my memory, I'm pretty sure on this, methods resolve from right to left, or sorry, not methods, classes resolve from right to left. The one on, or right, yeah, the one on the farthest right is the one that's like applied first, or applied last. So that's the one that matters, right? This is the one that like sets it up, and then this one, this one, this one. So this is the one that it ultimately gets. So if your shoe came last, the troll is going to say squeak instead of rar. The good thing is it's easy enough to like test these things out and like just swap a variable around or whatever and be like, oh, that's what it does. But yeah, Python's pretty good about applying things like in order. I've very rarely been surprised by class behavior. It does happen, but rarely. Okay. Super is good. We're okay on super. How are we on time? What time is it? Oh, I don't have a clock. It's 10:30. Cool. Man, we got another hour and a half. All right. You guys want to learn about magic? I promise to do jazz hands. Okay. So, the title of this one was, or is, Teach a New Object Old Tricks. That was my clever punny tutorial name. Originally, I was going to do just a thing on like how to take existing or how to make your objects work like existing built-in types, because that's fun to do. You're like, look, I made a list, but it's not a list, but it acts like a list. But A, there's not 2 hours of material there, and B, I wanted to be able to start at the beginning with objects. So now we're getting to that part. This is the fun part. So let's talk about magic methods. Actually, you know what? We've been here a while. Does anybody need a break for a minute? You good? I keep hearing clapping. I'm like, you're getting one talk for 3 talks time. No. I promise I was not cheesing for applause that time. You will know when that happens. I just keep noticing like, oh, their time ran out. They're done. I was tempted to take the half hour off and go watch Lacey's talk, so you're all lucky I'm here. We'll wait till he comes back. So anyway, yeah, object-oriented programming, it's a lot of fun. You'll find yourself, they're a hammer. You've heard the phrase, if all you have is a hammer, everything looks like a nail. Objects are a hammer, and you'll find yourself making objects where you don't need objects. But it's fine. They're a good solution for most problems that you'll encounter in Python. We're going to add more stuff to shoe, by the way. That's why I swapped back over to shoes. Okay, so let's talk about magic methods and what they are. If you do, let me just pull up. I'm just gonna do that. I'm gonna do it live. We'll see how well that works. Okay, I can type. Let's do a dir on list. Okay, you see all these ones up here that start with the double underscores and end with the double underscores? Or as I will from now on refer to them, dunder. Those are magic. And the reason they're magic, other than kind of looking like a top hat, is because you don't ever call them. So you use these all the time, you just don't know it. You never actually call them. That's what makes them magic methods. They're magically run. So, for instance, and we're gonna talk about this one. Wow, that's not what I wanted. ITER, right there. Any guesses on what that one does? I like that one because it's not even a word. It iterates, yes. It actually doesn't iterate. It's used in iteration. It returns a new iterable that something else can iterate over, right? So every time you do a for loop and you do for x in y, y runs its iter magic method and gives out this iterable that the for loop then goes through and calls each thing in at x. And it actually uses get item here to get x. So 2 magic methods for the price of 1. Oh, and now it won't shrink down.
How did you get this listed?
So I used dir, which I'm assuming stands for directory. I've never actually looked it up. You know what? Let's find out. Help dir. It doesn't say. All right. Thanks, help. So dir will show you all of the methods and attributes that belong to an object. And since everything's an object, it'll show you all the methods and attributes that belong to anything in Python. You can get nice and meta and start looking up like the help of dir and the dir of help. And yeah, help, for instance, has nothing but magic methods. And that's because help is a function. Functions don't really have attributes all that often, although you can use them if you want to. Stick attributes on your functions. Go for it. It's fun to do. Okay, so the first one I want to talk about, though, is init. And let's just collapse these things. These things are way too big.
Question?
Yeah.
How does dir differ from dunderdict?
How does dir differ from dunderdict?
Yeah.
So
I don't know if you can use it.
yeah, no, like if we do help.dict, there's nothing in there, right? So like if I do dir, wow, that's fun to do. Yeah, dict isn't always going to give you back stuff. It's going to depend on the construction of the object. We'll get to dict in a little bit. But what dict does is dict, when Python makes any object, and I mean anything, a function, a string, anything it wants, what it actually does is it has this name, and then it has a dictionary. And inside that dictionary is where it puts all of the attributes and methods that belong to that object. And it just stores them in a dictionary because dictionaries store really, really well. So whenever you reference something, it just goes and looks in that dictionary. You can get to that dictionary by looking at the magic dictionary. Dunderdict, dunder. Yeah. So dir is going to give you a better example of everything that's inside of an object than dict is. So generally you want to use dir. But dict does have its values. You have to enunciate that T as well. Otherwise it sounds horrible. Okay, so let's write a magic method. So this is init. And when we create a new instance, the first thing that happens is a method called dunder new. Dunder is run. And new actually builds the instance of the class. And then it hands it off to init. And init customizes that new object and then gives it out to the world. You don't customize new nearly as often as you customize init because usually you don't care about the creation process. You care more about the customization process. So we're going to add to this. Wow, I don't need to type self twice. We're going to give a default size, and we're going to give a default color. You can leave these blank if you want. And self.size equals size, self.color equals color. No returns. Don't put returns on your init. If you put a return on your init and it returns anything other than none, you get an error. So you'll know you did it really quickly. I'm also going to get rid of this shoe closet thing. Okay. Wow, that was my worst. That was my best yet. That was amazing. Okay, so we did this before, right? Can I get a knit and that on that? I can. We made shoes, we changed the color on the class, and then we printed the color on the shoe, and it's like, whoa, it's a different color. Oh. So my shoes are still red, and the reason my shoes are still red is because I set it on the instance right there. So anything you do inside there that talks about self, which is going to be pretty much everything, actually happens to the instance that you just created. So you've prevented that whole, oh, somebody changed the class and now my thing is weird problem. Thankfully, it doesn't happen a lot, but when it does happen, it's annoying. Init is also a really great place for, I want to do something when this object is created. I want to log a message. I want to start some other process. I need to start, a task worker over here to the side. I need to create 4 other class instances of something else and attach them to this one because our shoe has a laces class and a sole class and a cover. A box class. I don't know. I'm trying to think of shoe things. A heel class, whatever. So all of that goes into init, and that keeps everything to where it works at creation. It's all nice and neat in one little package. So any questions on init?
So when you say my shoes equals shoe, is there a way that let's say at that time define the color or something?
I have very small orange shoes. Yes.
What calls init?
What calls init? So when you... Okay, we can look at this in code. So right here, I say my shoes. That's just a variable, right? And then I do shoe and parentheses. And so Python goes, he wants a shoe. So it goes and it creates an instance of the shoe class. So it creates this instance in memory, and it runs a method that belongs to the shoe class that's known as dunder new. So underscore underscore new underscore underscore. And that goes through making an instance, putting it into memory, and here it is, right? Here's this ephemeral instance. And new gives that instance to init and calls init. And then in init, I have the instance, self, and then I can do things to it. So now I can do self equals size, or self.size equals size, self.color equals color, self.squeak equals true, whatever. And then init gives the object that has now been created and customized out to the world. So it goes off into nothingness, or it goes into a variable, or it goes to wherever. So Python calls new calls init calls whatever you tell it to call. By default, it doesn't call anything. It just sends the thing out. All right, everybody comfortable with init? You'll write a lot of inits. That's like the one, you write a class, you write the init, and you're done for most of the things. Not everything that you give, like this and this, don't have to be symmetrical. Like I could add in self.squeak. Yeah, it's AK, right? Yes. So now my shoes squeak, and I didn't define that. I have to override that on the instance myself later on. That's just like a default set, right? And you don't... Stop being weird on me, screen. You don't have to have these lines anymore either if you don't want them to. If you don't want to have those, don't have them, get rid of them. It doesn't matter at all.
Do you need to have size and color at all, or you're saying you want to assign them values?
Like, that's perfectly valid, right? Because, like, they don't need to be there because I'm setting them in the init. I generally prefer to leave them because it makes my design a little bit more obvious You can look at the class, see the attributes, and go, oh, those are the things that exist for this class. As opposed to having to open up the class, go look at the init, and then go, oh, that's the things that exist for this class.
So,
yeah.
Well, I'm just saying, you have to assign
Whoever.
values, or can you say that it has the sign?
Oh, like, could I get rid of the here? Could I get rid of the equal signs?
Yeah.
No. Because they're variables. We don't do...
You have to give an idea of what type it is.
Yeah, we don't do instantiated null variables in Python. So, yeah, we have to have values for them. Do you have a...
That was kind of my question, because if you don't, if you goes up there, then it looks like the default value is 9.5, and then it has a different default value.
Right, yeah, I could totally do that, and then it looks really weird.
So I was going to say, well, we didn't know if the documents that you affect size, but then that is the default value, so maybe you can reshape the knowledge.
So, what a lot of people would do, myself included, is you'll do something like this. And then size equals size or shoe.size. Oh, I'm sorry, yeah. So the question was about kind of a design approach. Do we need the size and color attributes up here? And if we do need them, if we have to say that they exist, can we just like leave them blank? And no, we don't have blank variables in Python. I mean, we have none, but that's a not blank thing. So like, how do you get around making sure that your attribute defaults that people would see and your init defaults in your init signature like match? How do you make sure they match, or do you care about that, or whatever? And so what I was getting at is that you don't have to have these defined. You can leave them out. Or what a lot of people do is you'll have basically just placeholders inside your init, and you'll set whatever those things are if something comes in. Otherwise, you go to like whatever the class has. So it's not... Actually, I guess that could be self.size. It's not the best approach doing it like this. It's a little bit weird to type, a little bit confusing, but it's perfectly doable. Most of the time, I leave the attributes on and just make sure the two things match, because it's easier to see what I'm intending when I glance at it and go, oh, I meant the size to be 9.5 by default. I can assume that my init's default is the same, but you don't have to. So if the values, if we had that, then the value in the init signature is what's going to be applied. Yeah, if you're going to override it, there's no point in having it defined both places. If you're not going to make them match. So long, with the none, it will go back and get the default values, so long as you're doing something like this, where you're saying, if they gave me a size, use that, otherwise get the size that I already had set. So you do or self.color. And that makes it to where if they pass in one, it uses that one. If they don't pass in one, it uses the default one. Whether this is too complicated of a design or too much typing or whatever is up to each of you to decide on your own. But it all works. And all your shoes have to squeak, because that's set to true and can't be overridden. Okay, any other questions about init? No? All right, let's talk about another magic method, because magic methods are fun. So this one is a transformative one. And I just made that word up for that moment. So str, any guesses on what str does? It does. It controls how your class instance turns itself into a string. Now, it doesn't make your class a string. It just makes it know how to become a string. So let's just return a string. I had tons of notes for this stuff. Okay, so we're just going to return a string, and we're going to put in the color, a comma, and then say size, whatever. So it'll be red, size 9.5. This is another place where I should probably mention for Python 2 people. Python 2's strings have to be ASCII. So if you think your string is going to end up containing Unicode, you want to override the Unicode method instead and use that all the time. Or just upgrade to Python 3, and then it's all Unicode everywhere. It's so nice. I'm serious. Once you figure out the encode-decode dance one time, you will convert the next day. Because the encode-decode dance is the worst thing ever. It's worse than time zones. No. It's not. Okay, so now... So I'll go back up here. There's the str. We're just returning a string. And then down here, instead of printing out the explicitly, myshoes.color, I'm just going to print out a string version of my shoes. Just turn this thing into a string and let me see what comes out. No. Because print doesn't turn things into strings. Or it shouldn't. What? This was not working earlier. Yeah, see, that's what I was going to get at, is you should also be overriding def repr, which is fun to say, and okay, I don't know why it's doing that. It should not be doing that. Should I upgrade my version of Python? Oh, no. I mean, it's 3.5. I know there's a thing where I can dump the... Whatever. Okay. By default, it shouldn't be doing that. Let's do it this way. From shoes, import shoe. I have a 1.2 sized foot. Wow, weird. That's what I'm expecting. Okay, maybe print does turn it into a string. Anyway, all right, consider me confused. This is that whole bugs and live demos thing that Melly was talking about. So this thing I have highlighted, this is called the representation of the object, or the repr, R-E-P-R. You can override dunder repr dunder. Weird sentence. And you can change what this does. So like if you've played with Django and you've like printed a Django model or inspected a Django model, and it'll have like the model name, colon, and then like instance at whatever, that's where they're kind of controlling this. They override the repr to make it look a little bit nicer when it prints out in the terminal, so you can kind of figure out what's going on. Repr is not nearly as overridden as string is, because do you really care about the memory address, like how that memory address prints out? Probably not, because you probably don't use that all that often. I know that I've never used 0x whatever to go look up an object in Python. Could that impact debug? Changing the repr, would that impact debugging? It shouldn't. The debugger is going to use the memory address, and it does that through ID. So it would do, ID new shoe and get out the actual memory address, and it would use that to go find the thing. It wouldn't use the repr to go find it. So repr is, that's human consumption. But you might end up hamstringing yourself if you were using, like a live error page, like I apologize to any German speakers, Werkzeug gives back, or like Django does, where it'll mention like a memory address, or it'll mention a certain object that has a problem, if you blanked out your repr, you might have a really hard time finding where that thing was that actually went wrong. But that would be about it. I mean, all of these methods are, for the most part, for you to consume. Python uses them internally, yes, but Python knows a whole lot more about your objects than you do. So if it needs to go find something, it can go find it. I've never heard of any problems with using the repr, with changing repr for doing that kind of thing. Okay, so I'm wrong on the string thing. It does it without str. Yeah.
Just out of curiosity, what if you ran an integer on that x? Would it not be the same as decimal ID?
I'm sorry. What was that?
On the you're looking at the ID versus the address.
Oh, on that?
Yeah. Is there any relationship between those two?
So is there any relationship between this address and this address?
Yeah.
There should be. They should be the same location. I don't know. It's been a long time since I've looked at those internals, so shrug. But I think they're the same. Or if they're not, then one of them is a reference to the other one.
What if you ran just x on the integer?
What, like turn that into an int? That's what, base? Yeah, it's hex. Whatever. Let's see. Help int. I know there's a way to specify the base. It's up here somewhere. There we go. Always trying to be helpful. Always putting in extra apostrophes. So yeah, there you go. Same place. That was fun. I haven't played with that in a while. So let's talk about numbers. We're going to do a whole new class for this. Whole new class. Yeah. All right. So we're going to make a song. Normally I'd give it a title, an artist, stuff like that, but I'm just going to do total seconds equals 0. And net. So this is going to, there's a typo? Aha. Yep, thank you. Blah, blah, blah. Right now we'll give that an ugly value error. In your own code, you should make nicer value errors than that. Seconds. Hours. I will walk through all of this in just a minute, because I know there's a lot here. Okay, that's all I'm going to type for now. I'll give you all a moment to catch up, and then we'll talk about what goes on here. In front of set? Yes. Yeah. We're going to talk about that in a minute, too. That's a special fun thing. Python's just full of little surprises. Okay, just to make sure, does the init confuse anyone? Just the init. The init makes sense, right? Okay. So let's talk about what set total seconds does for a minute. So it takes two arguments. It takes self, which is the instance, and it takes time, which is going to be our string that looks something like 00:00:00, so hours, minutes, seconds. I got to get used to doing this for all of you because you're reading that way instead of this way. So if our time count doesn't if our time doesn't count two colons in it, then we throw a value error because you gave us the wrong format. Your value is incorrect. And then we do seconds, minutes, hours equals map int time split :::::. -1. Let's break. I hated writing this line, and I was like, I don't want to write the for loop to make this work. So let's talk about what we're doing here. First, we're splitting our time on the colons, right? Everybody comfortable with splitting strings? We split the string on the colons. That gives us a list of 3 items: the hours, the minutes, the seconds. They're strings. Then we reverse that list with this : :::1. That reverses the list and gives us back a new list. That's the reverse of the first list. And then with map, we apply the int function to everything that's in that list. So instead of being strings, our hours, minutes, and seconds are now numbers. And they're all zeros by default. Yes? Yeah, you could have. Seconds is the thing I wanted to work with. And when I first tried writing this, I wanted to be like super clever and be like, oh, if there's anything above hours, just throw it away. And then I didn't want to go too far down that path, so I didn't. You could do that, though. You could add in like that, and then Python will just ignore that other stuff and go, oh, I don't care what you have there. It's not really worth the trouble, though. That was my original thought. And as so often happens, you have an original thought, you write your code that way, decide that original thought is stupid, and then don't change all of your code to match your new idea. So then our seconds, we increment by however many minutes times 60, because there's 60 seconds in a minute, and then however many hours by 3600, because there are 3600 seconds in an hour. And then we get back our seconds. So if something is an hour long, we get back 3600. If it's 2 hours long, we get back 7200. I'm not going to go higher than that on the spot. So the whole point of this is I want to be able to add 2 songs together and know how long their total playtime is. Right? Because if I'm making a playlist out of songs, ultimately that's how I figure out how long it takes to play that whole playlist, right? As I add all the songs together, I get that I have an hour and 20 minutes, and boom. Or if you're me, you have a 90s playlist that's 20 hours long. And that's just the way that adding works. Okay, but this is all we have. If I run this, I cannot add songs together. I can't do song plus song. That makes no sense. The operands, the 2 things on the sides, don't know how to add themselves to each other. So we got to fix that. So the first way that we can fix that, let's try making them numbers. And yes, I know int and init look a lot alike. So let's just send back the total seconds. Maybe adding, we just go straight to numbers. Right? Because adding, you add numbers, right? Maybe that works. It doesn't work. They still don't know how to add to each other. But it's cool, because now we have an int. So that's okay. That's better, right? So there's 2 really fun methods that you kind of have to override both of them on if you want to make your classes addable. That's totally a word. The first one is the obviously named add, which takes itself and takes an other thing to add to it. So we're going to return the int version of me plus the other thing. Whatever that other thing is, add it to the int version of me. Because we know if we turn ourselves into ints, we get back our total time, right? The song goes into an int, we get back the total seconds. Let's add that to whatever the other thing is. So any guesses on whether or not that's enough? It's not. The reason it's not is because our other is still a song. And we don't know how to add an int to a song, just like we don't know how to add a song to an int. So we get to override rad, which is not as rad as the name implies. It stands for reflected add. So basically we have 1 plus 2, right? And 2 doesn't know how to add itself to 1. So Python swaps them and makes it 2 plus 1 instead of 1 plus 2 and says, cool, can you add yourselves together now? And that's where rad comes in. Rad and add are often the exact same code because generally you want to do the same thing no matter which side of the operand you're on. You always want to add yourself to the other thing. So yeah, you could just have it return self.add other, but that's a little weird. And what if at one point your rad has to change? And now I get that it's 70 seconds. For 1 minute plus 10 seconds. 70 seconds. So we override add for being on the left side of the plus sign. We override rad for being on the right side of the plus sign. Cool? Now we can't do plus equals. You know how you've seen, like, x plus equals 5 to increment x by 5? That's a totally separate one, which I'm not going to go into overriding, but I want to talk about it, which is I-add for in-place add. So it just replaces it in place. Typically on this, you don't return and you just do... Actually, no, I guess you do return, but you just return self, whatever equals this plus that. I don't find I-add to be as useful. Although, it does make sense for like a playlist or something to be able to add multiple things into it as it goes on.
You say that I add.
No. I mean, you might be able to get by with like up in the init doing like self.dunder add equals self.dunder r add or I add or whatever. I wouldn't do that though. That's a little strange. Yeah. So we talked about adding. There's obviously other mathy things that can be done. You can subtract, multiply, divide, all that kind of stuff. Those all have dunder methods as well. So if you want to make sure that I want to add the same song to my playlist 5 times, so you need to know how to multiply yourself times 5, you would go and override dunder mul, and boom, now you can multiply your songs by a number. If you want to. Basically, all the mathy things work the same. I think the only difference is there's 1 or 2 that don't have the I version, like division doesn't have the I version, I don't think. I don't know. It's all in the docs. Most of the time you don't end up overriding these things. Add and multiply are pretty common because you want to be able to combine stuff. Division's not nearly as common. Okay, any questions on adding non-number things together? Yeah. Yeah, I didn't talk about that, did I?
Yeah, let's talk about your strategy.
Right. So the question is, why do we have this double underscore at the beginning of set total seconds? And since you obviously figured out part of that, you mentioned that it's private. Python, we don't have the idea of protected variables or private variables or anything like that. Like, In most of the languages, you're like, hey, this method is protected, nobody outside of the class can call it. Or private, nobody outside of the class can call it. And in Python, we don't really have that. Our one way of getting that is by starting a method name with a double underscore. If you do that, that method can only be called from inside the class. It's name munged. I do believe that's the technical term. Name munging makes it to where it can't be referenced from anywhere outside. So if I was to create a song instance and then try to call like thunder set total seconds on it, if I remember correctly, that will fail. It makes it to where it's private. It's called from inside the class. So you can't get to it from the outside world. You don't do this super often. This is also a bit of design information that you give to people. If you give them a class and you have a method that starts with a single underscore, the idea is, hey, this is my thing. It might change. You can use it if you need it, but it might change. Just, be aware. If you give them something with a double underscore at the beginning, the idea is you should consider this to be wildly changeable at any version of my software. Don't rely on this function. Because we might change how we define or how we find the total number of seconds in our songs. And if we do that, we don't want to have to warn people that, hey, this thing's going to change. That should be behind the scenes, and they just use methods to figure out the time already, which we're coming to in a minute. All right. Wow, I got through so much of that stuff. Cool. Okay. So, any other questions about init, int, add, or rad? Or starting methods with a double underscore to make them private? Okay. Let's talk about turning our classes into dictionaries or lists. We're actually just going to do a dictionary, but close enough. All right, let's go modify our monster. So, I want to say up front, this is a slightly iffy example, and it makes it to where your Python now behaves like JavaScript, so huge warning there. All right. Get item. Anytime that you reference something with brackets, with square brackets, you're trying to get something out of a list by index, you're trying to get a key out of a dictionary, that's kind of it. Anytime you're using those square brackets, Python calls this method called getItem, where it says, here you are, here's this item that I want, give me that item from somewhere inside of there. So, that's what we're going to do. That's what we're going to fake. We're going to do a try here, return self dot, remember that thing? Super duper simple. So what we're doing though is we're saying, hey, anytime somebody asks for an item, go see if that item exists on the object, and if it does, give it back. If you've played with JavaScript, you know that you can reference things as either dot attributes or as like keys. So where does the key come from?
Yeah, referencing key.
Oh yeah, sorry. Yeah, man, that's totally my.
Well, I was trying to stop him before you got involved.
Oh, I see what it is. So when I put this into my notes the other day, PyCharm put in self key, and then when I auto completed it today, it put in self item, or I mistyped it one of those two times. I'm gonna blame PyCharm though because it's PyCharm. Freaking IDEs. I used Vim for like 10 years, and then I was like, I should learn an IDE because that's what the industry uses, and just days of headaches. It at least has a decent Vim mode, so there's that. So now, what? Okay, sorry. Let me go over to these notes real quick, because these are slightly more up to date. I'm pretty sure I typed that in the same way both times, though. Oh, that was it. Haha. Okay, sorry. Let me change one thing real quick. Some things just cannot be typed. Yep. Yep. Ha! There we go. So now when we print the troll sound, we get well actually. So this makes your Python, sorry about that, this makes your Python act like JavaScript, because now you can get access to your attributes as both keys or attributes. I felt really dirty writing this because, I'm okay with making JavaScript act like Python, but making Python act like JavaScript is just horrible. When you're doing get item, where you're wanting to be able to get to stuff by brackets, the other common way that we end up checking to see if something is in something else is using the in keyword, in, like, if apple in apple pie kind of thing, if cheese in cheese shop. To do that, I'm not going to do it right now, but you override the contains method, and that's what does the lookup for you. Excuse me, that's what does the lookup to see if something is inside of something else. So if you're like, oh, I need to see if, my character has a big list of weapons, I need to see if axe is in the character weapons, then that's how you go look that up. That was a very constrained example there. I do believe I used that in a course. But that's what contains is for. All right. Any question over get item? Scroll back up. Yeah. Yeah, so what we had to do was we had to make sure that we set it on the attribute instead of going up to the class to try and find it. That self.dunderdict isn't going to look at the containing class.
Question?
Yes.
So with the init as it is now, you could get rid of the class system.
Yes. Yes, with the init as it is now, I could delete line 2 and it would be fine. There's only 2 more magic methods to talk about. And they're fun ones. Well, one of them is. Okay, so we're okay on our monsters for now? Alright. So monsters live in dungeons. Right? That's where I encounter them all, at least. And I want my dungeon to have trouble in it. And then for my init, all right. Nothing too special here. We have a dungeon. We have this default attribute called trouble, because you can go looking for trouble. Anyway, and then inside the init, we pass in monsters. Those monsters get added to our dungeon's trouble. So we're keeping that all fairly simple. This, by the way, would be a great place to go and add a dunder add for adding monsters into the dungeon. So, or an I add, I suppose. Dungeon plus equals, and then your new monster. Add that new monster in. So feel free to do that later if you want to. I won't assign it or anything, but okay. But what I want to be able to do is I want to be able to loop over all the monsters that are in my dungeon. I want to be able to go through them and fight all of them or vanquish them, whatever. First, though, I'm going to import random because everything should be random. So the way to make it to where your class can be iterated over, so it can be used in a for loop, is iter. I-T-E-R. We talked about this one earlier as being the way that we do iteration. And so then we're going to do random.shuffle self.trouble. And then we're going to return monster for monster in self.trouble. Or, as I wrote it, M for M. And we're returning a generator here with the parentheses. We have to return something that can be iterated over. And just in case your trouble is insanely large or your monsters are memory heavy or whatever, it's a little bit better to use this as a generator because then it doesn't consume a huge amount of memory. While I'm on the subject, generators completely new to anybody or confusing? Yeah? Okay. So normally we have like a list, right? And we have all these items that are in a list or a tuple or a dictionary or whatever. So all of those things are in memory, which if that list is really, really big, means that we're using up a lot of memory. What a generator does, though, is it figures out what the first thing is and how to figure out the rest of the things, and it remembers where it is. So it'll give you that first thing, and then it just holds on to that processing time for the other. I'll get to it later. I'll get to it when I need it. And then you ask for the next one, and it gives you the second one, and remembers where it is. The third one remembers where it is, and so on. So you're only having one thing in memory at a time, and like a pointer to how to figure out the rest of it, instead of the entire list all at once. So if my dungeon had 10,000 monsters in it, I probably don't want to hold on to all of that at once every time I'm iterating over this. I probably just care about the one I'm currently on. Okay. So let's add, we did the sound. Okay, cool. So let's use this. M1 equals monster, M2 equals monster, sound equals something, P1 equals troll, P2 equals troll. Oh yes, it should be a fairy tale, not an fairy tale. Ooh, don't want to offend the English majors. Sorry, I had fun with my trolls. It was just like, the internet's a horrible place. So the cool thing is that iter makes it to where I can do a for loop over it, or where I can turn it into a list. I'm consuming it into a list. That uses iter as well. So I will scroll up here, but if I print that, you can see that we have a monster, and then a troll, and then a troll, and then a monster. We got each thing back out in our new list. It's shuffled because we did the random.shuffle, but each thing came back out. So yeah, this would be a good place to go add in like add or iadd to be able to add more monsters to your dungeon if you want. But, you can do that at home. All right, so any questions about iter? Iterate. We'll say iter. No? Okay, cool. I hear people still typing, so I'll give you a second. Question?
So you could use that iter in list comprehension, so you can just list all style. You want to get an attribute of each of them.
Yeah, so could I use iter for a list comprehension or whatever if I wanted to do like m.sound for m in dungeon? Yes. So there we go. Yeah, so anytime that you're like, I have this thing, my class, and I need to be able to loop over it, that's when you're going to define iter, iter. This is actually one of the ones that I find the most useful, because you build up a big list full of stuff, and you want to be able to get through all of these things. I need to be able to process these in some way. So iter comes in really handy there. It's also one of those things like, if you start combining functional programming with object-oriented programming, you write a lot of stuff that consumes iterables. And so you want your classes to be iterable so that you can consume them and do whatever stuff you want with them. So that's really handy. Yes?
So when you did that, you got two rars instead of, well, actually, I assume one of those rars was code.
Yes.
And it's not clear to me what this means. Well, right, but we defined well actually in the past, not in an init.
I'm sorry. I missed the last little bit of that.
So is troll, if you're not passing in a new sound, it's getting it from monster class?
Right. So the question is, if I don't pass in a sound for troll, it gets it from the monster class. Yeah, because in troll, we never overrode the init.
Okay.
And so it never sets that init. If I was to, let's see, I'll
You have an init in monster. Okay.
yeah, I'll do this the right way, or self.sound. And then if I come down here, oh, but I love that one. So we'll add in a new one. P3. So now we should get a well actually, and then two that aren't. So there we go. Yeah. It's sometimes hard for me to come up with trolly words. So when I have a couple of them, I just enjoy it. But yeah, so this is where, again, it goes back to that, like, oh, I've got to build this class correctly so that this thing comes through and that thing comes through, and you just, yeah. Yes, thank you. Thank you for asking that. Okay, you ready for the last one, which is the one that, like, confused me so much when I first learned it. So I'm going to try and not confuse you, but I make no promises. But we will go over it repeatedly until we all get it. All right, so when we want to make if you have a string and you want to make it into a list, you use the list function, right? You use list and two parentheses with your string inside of it. Or if you have a number and you want to make it a string, or a string and you want to make it a number, then you use str or int or float or whatever. But the weird thing is, you're not using a function when you do float parens. You're actually using the float class. You're calling the class like it's a function, which is fun. Let's make a class that we can call like it's a function. So we're going to call this add. And add doesn't do anything special. Inside the init, though, we're going to say default 0. We're going to add more to this in a minute. Okay, so we have this class called add. When we instantiate add, we give it a number, and this is the default number. So this is where we're always going to start, is whatever this default number is. If we don't give it 1, it starts at 0, but that's where it comes in. And now we're going to call. And call is going to take an argument as well called extra. And we're going to return self.default plus extra. So we've made an instance that we can now use as a function and pass it a new argument, which gets thrown to this call function, and then we get back an answer from.
Call function is invoked, right? Whenever you use that, you refer to the variable as a function.
Yes, the call method is used, and it's fine. It's weird that we have two names. The call method is called whenever you use an instance of the class as a function. Yeah. But this is actually really cool. This is really handy because you can instantiate, like, say, people. And you give them a name, you instantiate all these people. And then maybe you have it set up so whenever you call, wow, that person, it prints their name to the screen, or it emails them, or it just pulls up their information, or it does whatever. So it makes it to where you can start to make your instances behave like data and like functionality. It's not something you're going to do with every class you make, obviously. But when it does become handy, it is really handy. And to me, stuff like this, I mean, like add, whatever. Add's not all that handy. But there are a lot of places where this is useful. And this is very similar to what, like, Python does with, like, turning something into a list, turning something into a string. It uses, effectively, this. You can also write, I mentioned earlier that decorators were functions. You can write decorators as classes, and you just make it to where you can call them. And then, hey, now your class is a decorator, and you can, put more nicely organized information into it. Don't just go off writing decorators, though. Decorators are weird and hard to get your head around. And if I wanted to, I could be like, yeah, I did a workshop on Treehouse about decorators that you can watch if you want, but I'm not going to do that. Because I'm not going to just constantly talk about my stuff. Okay, call. Any questions, any weirdness about call? No? All right. I kind of feel like I've ramped up the weird things as we've gone along. This next one starts off so nice and then becomes so weird by the end. So I apologize first. Okay, so when we're dealing with object-oriented programming, emulation comes up a lot, which is what we've been doing, right? We've been emulating dictionaries, we've been emulating strings, we've been emulating functions, whatever. So we're pretending to be something else. One of the other big parts that comes up is encapsulation. And there's kind of two bits to encapsulation. One is I'm going to have this nice little package that I can give you that has data and methods for working on that data. That's called a class in Python. That's just there by default. The other bit of encapsulation is controlling access to data. And we already did part of that with the dunder set whatever. We can mark this function or this method as being private and being scoped just to this class. The other way to do that, though, is through properties. So, a property is a method, but it pretends to be an attribute. Let's make one real quick. I'm just going to do it here in the adding class, or adding module, even though it's not part of adding. So, first things first. Import datetime. And we're going to make a person. And okay, so nothing special there. I'm just setting a couple of values or a couple of attributes onto the instance. Okay? So now I'm going to make days alive. I'm going to return datetime.day minus self.date.days. Okay. So I have a method now called daysAlive that takes whatever today is and whatever day the birth date was, subtracts one from the other, and returns the number of days in between. Not 100% accurate, but not terrible. I'm going to use myself. Nobody steal my identity, please. Now that you have my birth date and my name. Okay. So, if I print out me.birth, or days alive, I run that, we get 12,000. 12 and a half. Okay, so that's cool. But days alive is a method. I have to remember to call it. It's, maybe I just want to be able to reference this as an attribute on somebody. So now I make it a property. And I get a type error because you can't call ints. And I take off these parens, and it shows back up again. So it's a method that pretends to be an attribute. Okay? I can't call it. For all intents and purposes, it's an attribute. So that's cool. That's handy when you have something you need to calculate. Basically, that's the idea. I have an attribute. I want it to be an attribute, but I have to calculate it. I have to do something with it to get it. How do I do that? I make it a property. Yeah.
Is that your way of shortcutting all the things you have to do with less edible,
So would there be a way to shortcut all the add, subtract, stuff like that? I don't know if there's in the standard library. I would not be surprised if there is a library out there that will automatically add those things for you. Add in those, maybe you specify a couple of particular attributes, and then it can add the methods for you that use those attributes to do the mathy stuff. I wouldn't be surprised if that exists. Are you trying to do more for property, like? So could you hide them using property? Maybe. I don't know. Yeah, I would assume it's probably better to go the paved path rather than forging your own trail through the woods of how can I fake Python out. Generally, you don't want to fake Python out. But maybe you have a wonderful use case. I don't know. Okay, so this is just a property, right? And so if I wanted to, like, if I only know that this is an attribute, then I should be able to set my days alive equal to 60, right? But you can't because you can't, it's an attribute. I should be able to set an attribute. But you can't set an attribute because it's actually a property. So let's talk about how to do that. That part's where it gets fun. And by fun, I'm using a lot of sarcasm. Okay, so we're back to our song. All right. So we have our song. Nothing is going to change about a lot of this. I promise. But some of it is going to change. So let's do by default, and we're going to comment that out. So we're going to automatically set all of our songs to have a total seconds of 0. None of our songs have any time at all to them, which is, pretty common, right? And then we're going to add a new property. Total seconds. So we're going to return our total seconds. So now, I still have my mathy thing at the bottom. 0, because 0 seconds plus 0 seconds is 0 seconds, right? Okay, but I need to be able to actually set the time of the song. It needs to be settable. Okay, and by the way, I'm not saying that what we're about to do is better than our old way of doing it. It's just a different way of doing it, and it has some pros and cons. Okay, so let's talk about how to set properties. Because you can do it. You totally can, I promise. That's the magic line. So, total seconds is our property, and then we're going to define the setter for it. And then we're going to do total seconds. They don't have to be the same name. That's just pretty common. And then actually, I'm going to take all of this, copy, paste. Aha, it worked. Okay. And then we do have to change one thing, though, which is we don't return seconds at the bottom. We say self.total seconds. Equals the seconds that we just did. So it's the same function that we had before, same method we had before. You could just rename it, move it up, whatever. Leave it alone, whatever. And so what this does is now, anytime somebody calls, hey, set the total seconds, then it'll do that. It'll use this function instead, this method. But we still get 0 because we haven't told it to do that anywhere. Excuse me. So we have to tell it to do that. So up here, we have that one. Sorry, I gotta look at my thing here. There we go. Time. And now when we run it, we get 70 again. So this line is also our magic line. What we did was we said, hey, go back, set your total seconds equal to the time that just came in. When the time comes in, we convert it into our seconds, right? Through all of our flippy-floppy of lists and turning things into ints and all that stuff. So anytime I ask for total seconds now, I get the calculated total seconds. If I try to set it, I have to send in the timestamp, and then it'll calculate it and set it for me. This is, like I said, this is not a better solution, but it is another solution. This does become kind of handier for if I want to be able to set the time on a song after it's been set. Maybe my music player or whatever misread the time, and I want to manually update it. Now I can just go, no, hey, your total seconds is actually 310. It's not 300. You need to get that time right, and it can be updated. That said, I should probably just fix whatever bug caused the time to not be read right.
Question.
Yeah.
At your init?
In my init. Yes.
So if you're setting the total seconds properly, you need the line above it.
Do I need this line?
Yeah.
Yeah, because if for some reason this never runs, this still has to be able to return something. Right? So if def total seconds as a setter, there, if that never runs, okay, whatever. If that never runs, then the top one, the property one, actually needs to run. And so when it runs, it's trying to return an attribute. And if that attribute doesn't exist, we get an attribute error instead of anything. And we don't want that. We want to actually get back a value.
So the third line in the init, isn't it calling the setter?
Yes, this one calls the setter. But if I leave that off, right?
No, I'm going to say to leave off line 6.
So like this, it's fine. But like this, it would fail.
Right.
So in the interest of being safe, so that it can't break, I want to include both of those lines. Right? Just in case, because you never know, right? This also comes like another thing that starts to come about after this. Once you get properties and setters, you start going, oh, well, I want to be able to control how a property can be set, or how anything can be done, right? How an attribute can be set. And you start getting into descriptors where you write classes that control how your classes add values to themselves. And it goes down this giant rabbit hole that never really ends. And so, yeah, that's like your next step. I'm not going to go into descriptors because there's a lot there. And I actually did pretty well on time. I'm normally like way over or way under. So we're good. We're done. Any questions about the whole thing? I'm happy to answer. Yeah.
So, is there a way to make the attributes sort of private? Sometimes you have a module with classes in it, and you only want people to access the attributes via your methods. You don't want them accessing them directly. Is there a way to do that?
So is there a way to prevent people from directly accessing an attribute? Yeah. As you might guess, it's a magic method. There's a magic method which is, it's either get attribute or get attr. I don't remember which one it is. And that controls attribute lookup. And so you can basically go override that one, and you can make it to where like nobody can get an attribute.
So you could do that as part of the init. You would call the set as part of the init.
Well, so that controls getting an attribute, not setting an attribute.
Well, I'm just saying, how do you call this? When do you call the get at leave the magic get adder to set things up so that access an attribute directly?
Okay, so how do you set it up? So you would define it on your class. So you're making your class, you go and you define dunder get adder, and you basically say return none or raise attribute error or whatever, right? And so then anytime anyone asks for that attribute, they get an exception or a none or a, go look somewhere else, buddy, or whatever. And that's it, right? There's no way to get to those attributes. And then your set attribute still works like normal, so you can still define and set attributes. Just nobody can then get them off. Your object becomes a black hole as far as attributes are concerned. But your properties should still be accessible. So they'd be able to. And the method should be as well. They should be, yeah.
So if you always want to say if you want size, you have to call my method.
Right. And you could also put like a whitelist into there and be like, these methods are allowed, these attributes are allowed, whatever. If it's not in this list, raise an error. If it is in this list, go ahead and give it to them. So, I mean, you've got full control over that kind of stuff. That's a little weird Python design-wise, as far as usually things are wide open. I mean, we're a trusting bunch. We don't really care. But yeah, that's the way you do it, is you override get attribute. Well, okay, the Python ethos is that we're open and friendly. Real world scenarios, what's the thing? The best laid plans don't encounter or don't survive first contact with the enemy. Yeah, first contact with the enemy. Yeah, same idea, right? We're all gonna be super nice and open, and then client demands come in and nothing's open. Okay, well, yeah. So from a design standpoint, is it better to do named keyword args like this or to do ** kwargs? It really kind of comes down to how prescriptive you want to be on your software. If you want only X, Y, and Z attributes coming in on initialization, name them, right? Tell me. Don't let me do something else. But if you don't care and you're just like, yeah, set whatever attributes you want and I'll, make them available or I'll use them or I'll do whatever, then open that up too. It really comes down, yeah, every object's going to be different. The ** kwargs thing is super common though. So you'll probably find that more places than you won't, even inside of Python itself. All right, so everything's online. If you missed anything or you want to go through the code again or whatever, it's an interactive IPython notebook, so you can just change the code there and run it and see what breaks or doesn't, which is kind of fun. And I'm online. Where's my alarm? I'm online everywhere, and I'm happy to answer questions. So thank you all for coming.